Good day. Today, we will dedicate our time to an extremely relevant topic, the visualization of logistics data and the principles of building dashboards and business intelligence systems.
Managing modern supply chains involves the continuous generation of colossal arrays of information, from minute-by-minute vehicle coordinates to microscopic calculations of the cost of each warehouse operation. However, the simple accumulation of these numbers in corporate databases holds no managerial value until they are transformed into clear, visually understandable forms for timely decision-making. We will examine fundamental approaches to presenting analytical information, analyze key mistakes in report creation, and determine how to turn disparate, complex tables into a powerful tool for monitoring and control. The ability to work with information arrays and present them correctly is one of the core competencies of a modern specialist who can see real logistics processes behind dry figures, predict risks, and promptly eliminate bottlenecks.
Computer systems work perfectly with databases, processing millions of records in a flash. However, the human brain has its own cognitive load limitations and perceives solid tabular arrays very poorly. Imagine a very real situation. A financial director is given a spreadsheet export of 50,000 rows containing transactions of daily transport expenses. In such a huge volume of unstructured numbers, it is physically impossible to see hidden seasonal trends, detect a gradual increase in fuel costs, or sharp anomalous spikes in contractor tariffs. This is why the main task of visualization in logistics is to translate complex mathematical analysis results into the language of rapid visual perception. The graphical representation of information allows for the identification of a critical problem in a matter of seconds. For example, if we look at the linear dynamics of costs, we will immediately notice a sharp anomaly in December, a jump in expenses to $4,800. In a spreadsheet, this figure would simply be lost among thousands of others, but on a chart, it instantly signals the need for managerial intervention. One fundamental rule should be remembered. An effective logistics chart is not just a bright picture to decorate a corporate report. It is a rigorous analytical tool. It is developed exclusively to save time on decision-making and to clearly highlight deviations in supply chains.
Let's consider the fundamental rules for building logistics charts, which are based on the concept of minimizing visual noise. Professional analytics does not tolerate embellishments, and its main task is to show objective reality. The first and most important rule of data hygiene is the absolute rejection of any three-dimensional effects. A classic anti-example is the 3D pie chart. Due to optical distortion, the sector closer to the viewer will always appear visually larger than the one further away, even if their mathematical values are identical. Imagine a situation where you are analyzing the shares of cargo processing by different contractors. Due to such a 3D manipulation, a company with an objectively smaller volume of work performed may appear to be the leader simply because of a favorable angle on the chart. That is why professional data is always presented strictly in a two-dimensional format. This is the only guarantee of honest proportions. The second important aspect is the rejection of unnecessary decor. Various artistic shadows, complex gradient fills, and overloaded and overly bright grid lines in the background only distract attention. A true analytical tool should be as clean and concise as possible. In such a strict system, color becomes a powerful managerial signal. It is used not for aesthetics, but exclusively for contrasting deviations. Suppose we are tracking fuel costs throughout the year. If the indicators for 11 months are within the norm, it is advisable to leave the columns in a neutral gray color. And only one problematic month where a sharp budget overrun occurred is automatically colored in a signal red. This approach instantly focuses the manager's attention on the problem, allowing them to immediately proceed to finding the causes, instead of wandering their eyes over the chart. A common mistake when preparing reports is choosing a chart type simply for the sake of visual diversity, when in fact, each analytical task should correspond to its specific tool.
The choice is always dictated exclusively by the nature of the logistics data we want to present. When it is necessary to analyze the change of indicators over time, the only correct choice is a line chart. It is ideal for tracking fluctuations in shipment volumes, allowing for clear identification of seasonality or forecasting peak loads. For comparing different categories with each other, a column or bar chart is most often used. This is a classic and very convenient format for visualizing the results of a classic ABC analysis or comparing the cost of services from several carriers. Pay attention to a professional detail. If the names of companies or categories are long, it is worth using a horizontal orientation of the bars. This way, the text will be read naturally from left to right, without the need to tilt your head. If the task is to assess the structure of a certain whole, that is, shares of 100%, we turn to a pie chart. For example, it can clearly show the shares of different reasons for product returns. However, there is a very strict limit here, a maximum of 5 to 6 sectors. Exceeding this limit turns the chart into an unreadable mess, where small shares simply merge. To search for hidden patterns, a scatter plot is used, which displays the correlation and relationship between two different variables. For example, it can be used to visually test the hypothesis of whether the weight of a cargo directly affects the total time of its delivery to the end customer. And finally, a heat map is an excellent tool for displaying the intensity of certain processes. Imagine a warehouse workload matrix, where the intensity of operations by hours or days of the week is highlighted by color saturation. Such a format allows a manager to instantly understand the hottest periods and timely bring additional line staff to the loading docks. In summary, a correctly chosen chart allows a manager to make an accurate and well-founded conclusion in a matter of seconds, without delving into the primary data arrays at all. Once we know how to choose the right chart types for specific analytical tasks, the next challenge arises. A single chart provides an answer to only one narrow question. However, for the comprehensive management of supply chains, there are dozens of such questions. Consequently, managers need a tool that consolidates key performance indicators from various systems, warehouse, transport, financial, into a single visual space. This tool is the dashboard. When designing it, there is one fundamental rule. There is no universal dashboard. An information panel simply cannot be equally useful for all company employees. The detailed information that for a warehouse shift supervisor becomes miserable noise for the CEO, which only gets in the way. That is why modern business analytics employs a strict three-tiered architecture, which is formed according to the managerial flight altitude of a specific user. The first tier is the strategic level. It is intended for top-level executives and focuses exclusively on global macro indicators and the company's financial metrics. The second tier is tactical. This is a working tool for middle managers, whose task is to monitor processes, analyze contractor performance, and search for systemic deviations. And the third tier is operational. It is created for line staff who are directly in the field, where the situation changes and requires an immediate real-time response. This hierarchical division ensures that each employee. Let's consider the highest tier of our architecture, the strategic level. It can be compared to viewing the business from an altitude of 10,000 meters. This information panel is created exclusively for top management, the CEO or the director of logistics. Its main purpose is not to solve daily problems, but to track global trends, control financial results, and monitor the achievement of the company's strategic goals. Top management must be able to read the objective macro picture of the efficiency of all supply chains in a few seconds. Therefore, only high-level metrics are used here. For example, the total logistics costs indicator, logistics costs, which is usually analyzed as a percentage of total revenue. Next to it is the global perfect order indicator, global OTIF, which reflects the quality of service across the entire network in percentage terms. Another necessary important marker is capital in stock, which shows the amount of funds temporarily frozen in warehouse inventories. For a company's leader, a volume of $12.5 million of frozen capital is an indicator for making financial decisions regarding procurement policy, not a reason to search for a specific delayed pallet in one of the warehouses. The cost dynamics chart in relation to revenue since the beginning of the year, cost versus revenue YTD, provides a fundamental understanding of the long-term profitability of the logistics system. Since such macro indicators are formed gradually and do not experience sharp fluctuations every minute, the strategic dashboard does not require real-time updates. The information on it is usually updated once a week or once a month. The main rule for developing strategic panels applies here without compromise: minimum operational details and maximum aggregated financial data for making well-considered.
Descending a step lower in the management hierarchy, we move to the tactical level. This information panel is designed for middle managers, heads of warehouse complexes, chiefs of transport departments, or regional hubs. Here, the focus shifts from global financial trends to identifying specific deviations from the plan and searching for bottlenecks in daily operations. The metrics become much more detailed. For example, we analyze in detail the CPO, cost per order indicator, broken down by days of the week. If the cost of processing suddenly increases on a Wednesday, the warehouse manager must analyze the reasons for this inefficiency. Another extremely important tool is monitoring the service level, or SLA, of our carriers. If one of the logistics partners shows a drop in delivery quality to 75%, while others maintain a level above 92%, this is a direct signal for the transport department to immediately redistribute cargo volumes in favor of more reliable contractors. Also at this level, the percentage of defects or picking errors is strictly controlled. Since tactical decisions require prompt intervention in processes, information cannot be updated once a week. Data must be updated daily or even several times a day. This provides the manager with the necessary depth of detail for the timely detection of inefficiency and work correction. Descending to the base level of our architecture, we find ourselves at the operational level, where the principle of here and now reaction prevails. This toolkit is created directly for line staff, dispatchers of transport departments, and senior shift leaders. Their key task is not to analyze general long-term trends, but to effectively manage physical logistics processes and respond instantly to incidents throughout the workday. Here, the metrics are as specific as possible and tied to current physical processes. An employee is interested in the immediate situation at the facility. For example, the current queue at the ramp if 4 vehicles are idle there, or the status of an important hot order, the processing time for which is rapidly expiring. Since the situation in the warehouse or on the loading dock changes continuously, the data on such panels is updated in real time, usually with a minimal interval of 1 to 5 minutes. A critically important nuance of this level is the change in the very format of interaction with information. For employees who are constantly on the move in the field, classic stationary monitors are completely impractical. Therefore, interface development is oriented towards a mobile-first design. Optimized micro-dashboards are created for the screens of industrial scanners or rugged portable terminals. Such an interface is deliberately devoid of complex details and small elements. It displays only the most critical indicators in the form of large cards or bright color-coded notifications. This allows for instantly attracting the attention of a line manager for a quick reallocation of resources, say to urgently send additional loaders to an overloaded area, without any need to return to a computer. When designing information panels, it is necessary to consider the physiology of visual information perception. A person reads a monitor screen in the same way as a page of a printed book, from left to right and from top to bottom. In analytical design, this feature is known as the F pattern. A properly constructed dashboard uses this principle, distributing information according to an inverted pyramid model. The most important area is the top row. This is where the user's maximum attention is drawn, so it traditionally houses the so-called key performance indicator cards. These are 3 to 4 main metrics in the form of large numbers,
which are necessarily accompanied by a trend indicator, for example, a visual arrow that instantly shows the deviation from the plan. The middle part of the screen is allocated for providing context. This is where dynamics charts and various comparative diagrams are placed. This tier answers the question, how exactly did the processes lead to the large numbers we see at the top? The bottom part of the information panel is the details area. This is where extended tables with the most granular data are located. For example, this could be a list of specific problematic invoices or a detailed rating of routes. The logic of such ergonomics is extremely pragmatic. A manager looks down at the bottom tabular part only when they have seen a problem signal at the upper levels. If the key indicators are normal, the need to study detailed data arrays simply disappears, which significantly optimizes decision-making time.
A static information panel on a monitor screen is actually not much different from a regular printed sheet. If the system does not allow the user to interact with the data, the logistics department will have to constantly generate dozens of different reports for each new management request. Therefore, modern analytical solutions are built on the principle of deep interactivity, which makes them much more than just a report. The basic tool for such interaction is the slicers block, or slicers. Usually, this filter pane is located on the left or at the top of the screen. Thanks to it, a manager can filter the entire information array by the required parameters in one click: time period, geography, or a specific product category. For example, by selecting only the southern region in the filter, the user initiates an instant recalculation of all charts, getting a picture exclusively for that location. However, an even more powerful analytical mechanism is the drill down function, which literally means the ability to drill down into the data. Let's imagine a very typical situation. A chart at the tactical level records a sharp increase in the number of delivery delays. Instead of creating a technical task for the IT department for an additional data export from the database, the manager simply clicks on this problematic column of the diagram. The system reacts instantly and details the aggregated indicator, displaying a list of specific problematic invoices or order numbers, for example, order number 56789, that directly caused the deterioration of the overall statistics. This ensures a quick and seamless transition from stating a global problem at the country or region level to pinpointing its root cause at the level of a specific product or vehicle. It is this approach that turns working with data into an effective tool for the operational resolution of logistics incidents. Spreadsheets, which you are all well acquainted with, are an excellent tool, but only for basic, so-called ad hoc analytics. That is, for a quick one-time analysis of small information arrays. However, when a large logistics company generates hundreds of thousands of transactions daily, regular files simply cannot handle it. They freeze, complex formulas break, and analysts spend precious hours just mechanically compiling the numbers. To move to a fundamentally new level of management, corporations implement business intelligence, or BI, systems. The most popular solutions on the market are Microsoft Power BI, Tableau, and ClickSense. It is important to clearly understand the architecture. A BI system is not a database and not an accounting program. It is a powerful, intelligent superstructure, an analytical layer that connects to the company's existing databases. The greatest value of such systems lies in their ability to overcome so-called information silos. Let's analyze a classic logistics case. A warehouse management system, WMS, perfectly records the picking speed of a specific pallet. A transport management system, TMS, knows the exact cost of delivering this pallet to the client. At the same time, a financial ERP system contains information about the commercial margin of the product on that pallet. The problem is that none of these three systems sees the whole picture. This is where the process called ETL, extract, transform, and load, comes into play. The BI system automatically extracts raw data from all isolated sources, cleans it, and links it into a single coherent data model using a common identifier, for example, a unique order number. And only after this complex automated work does the manager get the opportunity to see on one dashboard the real end-to-end profitability of each order, taking into account absolutely all costs, from the warehouse shelf to the end consumer's door.
The traditional approach to corporate reporting usually involved the active participation of programmers, where any change in a chart or the addition of a new indicator turned into a long technical task for the IT department. Modern analytical platforms are radically changing this paradigm thanks to the self-service approach, or self-service BI. After architects have set up a correct and reliable model once, a logistics specialist no longer needs to have SQL query writing skills. Thanks to an intuitive interface, one can independently select the necessary metrics, drag them onto the canvas, and create their own reports to test working hypotheses in literally a matter of minutes.
The next, even more powerful evolutionary step is the direct integration of artificial intelligence and large language models into business analytics systems. With such technology, the information panel ceases to be just a passive display of numbers and turns into a proactive assistant. The need to spend precious time on detective work is eliminated. The algorithm itself highlights the insight, allowing the manager to focus all efforts on quickly resolving the problem.
Today, the evolution of data visualization does not stop at traditional dashboards. For managing truly complex and large-scale infrastructure objects, analytics goes far beyond flat two-dimensional charts. The latest industry standard is the implementation of so-called digital twins. Imagine an absolutely accurate scaled 3D copy of a real large distribution center or port terminal being reproduced on the screen. Thanks to continuous integration with thousands of industrial IoT sensors installed on the physical object, this virtual model lives a life completely synchronous with its real prototype. The manager sees not just aggregated statistics, but the realistic movement of 3D models of forklifts and personnel between aisles. Moreover, a color heat map is overlaid directly onto the virtual multi-level racks in real time, instantly highlighting zones of critical load, or conversely, idle equipment. Such technology radically changes the approach to operations management. The manager gets the opportunity to exercise unprecedented visual control over a huge logistics hub, as if from a bird's eye view. This allows for optimizing the routes of pickers and managing equipment flows, neutralizing the risk of traffic jams in warehouse aisles, even before they lead to a real stoppage of physical processes.
To summarize our conversation today, I want to emphasize the fundamental paradigm shift in our profession. The management of modern logistics has long ceased to be a craft that relies solely on professional intuition or situational guesses. Today, it is a precise, mathematically grounded engineering discipline. In today's highly competitive market, the winner is not the company that owns the most warehouse space or has the largest fleet of trucks. The undisputed leader is the business that can faster than others transform colossal arrays of raw data into correct and timely managerial decisions. A well-designed visualization system and the deep implementation of business intelligence tools do much more than just generate beautiful charts for management. They create a so-called single version of the truth for all company departments without exception. This is the very mechanism that allows turning the chaos of tens of thousands of daily transactions into a completely transparent, manageable, and predictable space, where every action has its justification and a measurable result.